The last learning outcome for subtopic stress and strain is discuss graph of force versus elongation for brittle and ductile materials. Figure 11.2 show the graph of stress versus strain for a various material. From the pattern of stress versus strain, we can categorize the material either it is ductile or brittle. The graph of stress versus strain is similar with graph of force versus elongation. The behavior of material also can be deduced in form of graph force versus elongation. The blue line represents a brittle material. This material also strong because there is little strain for a high stress. The fracture of brittle material is sudden without or little plastic deformation. In the brittle material, there is no necking process involved. From the graph, also clearly see that the material can withstand a high stress with a small elongation. The red line shows a strong material which is not ductile. Steel wires stretch very little and break suddenly. Green one show a ductile material. After the elastic region, there is a strain section where necking occurs. The permanent deformation occurs in this plastic region. And the last one is stand for plastic material. The plastic material will elongate more with a small force. As mentioned before, the characteristic or the behavior of material can be deduced from the graph of stress versus strain or force versus extension. The graph of force versus extension is similar with the graph of stress versus strain. The behavior of material can be explained from the 5 stages. There are: point A, proportional limit; point B, elastic limit; point C, initial point of plastic deformation; point D, ultimate stress or maximum force; and the last one, point E, is fracture point. For ductile material, there will be elastic and plastic deformation, whereas for brittle material there is only elastic deformation. The brittle material will not undergo the plastic deformation. There is necking occur in ductile material during the tensile test. But in brittle material, there is no necking process during the tensile test. That's all what you need to learn in subtopic stress and strain. Thank you. Have a nice day.